All right, this is the first video in 6.5 section. This particular section is going to be talking about equations with radicals, okay, with roots. If you notice in this one, here's a root here, and with exponents. Okay, and rational exponents, remember we talked about in the last section, rational exponent is an exponent that has a fraction there. Okay, so we're going to get to this in the second video. This will be in the first one, which is going to be right here. Okay, but before we get to this, let's kind of get some notes here. So what we got to do is this. So there are some steps whenever we have a radical in an equation. Okay, there's a couple things. One is we need to isolate the root. Isolate the root, or the radical, however you want to say it. So it doesn't matter if it's a square root, because that's what this one is here, or if it's a cubed root or a fourth root or a fifth root, whatever it is. First, we have to isolate the root. So in this one here, it's 6 times that root. Well, I need to get rid of the 6 because the 6 is not underneath it. Okay, so what I'm going to do is I'm going to divide both sides by 6. That's a novel concept, right? So I have the square root of 10m plus 11 equals 9. Then the second step is you're going to, once you isolate, so it could be adding, subtracting, multiplying, dividing to both sides. In this case, it was just straight up division to both sides. We'll get to some other ones where it'll be a little bit different, but the same general concept, isolate the variable, or isolate the root there, right? So the second step there in this particular instance is to raise both sides of the equation. So I'm just going to say both sides here. Raise both sides to the index. Okay, in this case, what is the index? Remember we said it was a 2. So I'm going to take both sides and I'm going to raise it to the 2 power. I'm going to raise this to the 2 power. Remember, what I do to one side, I have to do to the other. Then the third step is to solve the remaining equation. Remaining, there we go. Equation. What does that mean? Anytime I square a square root, or if I raise a root to the index, which is right here, right? This is the index. If I've also put that up here and I'm raising it, then I only get what's left inside. So it's 10m plus 11 equals, this is 81. Now this is a multi-step equation. Actually, it's 2 steps, so it's a little easier. Minus 11, 10m equals 70, m equals 7. Sorry, m equals 7. Now, m equals 7, which we think is right. Okay, so I think this is right. But up here it says, remember to check for extraneous solutions. What does that mean? That means that I need to check my answer. Some of these numbers will not work out, and we'll get to some that don't, so you can see the difference. But so what I'm going to do is I'm going to plug this back in. So it's 6 times the root of 10 times 7 plus 11 equals 54. 10 times 7 is 70. 70 plus 11 is 81. 6 times the root of 81 equals 54. Sorry, 54. What's the root of 81? Well, that's 9. 9 times 6 is 54. So this does check out. Therefore, my answer is m equals 7. Okay, we have to check. So that would be the fourth step, would be check solution in problem. So like plug it back in and check. Okay, we have to do that. That is part of our rules here. So let's go on to some more problems. Let's look at this one here. Again, first one I want to isolate. Isolate. Well, what is in the root? That is the root. I want this to be over here. So I got to add 2, add 2. So I have the square root then, right there, of 6n plus 4 equals 8. The index, remember the second one is raise to the index. What is the index? The index is 2, so I'm going to raise both sides to 2. So remember I talked about if you raise a root to the index, you get what's inside. 6n plus 4 equals, this is 64. 6n equals 60 minus 4 to both sides. N equals 10. So that was the third step, right? To solve. And then the fourth step is to check. So plug it in. Root 10 times 6 is 60. Plus 4 is root 64, which is 8. Minus the 2, which is 6. So that does work. So that's why n equals 10 is my answer. Okay, hopefully this is kind of making a little bit more sense. This is not really that bad. These topics aren't that, this section's not that terrible. But we'll get into some other ones here. What about this one here? This one looks kind of crazy. So the first step was to isolate root. Isolate the root. Well, aren't both of these isolated, right? This is a root here, this is a root here. They're already isolated. So what do? I square both sides, raise it to the power, or raise it to the index, right? So then that's 9v, this is 8v plus 1, subtract v equals 1, boom. Let's see if it works. 9 times 1 is 9, square root of 9 is 3. 8 times 1 is 8, plus 1 is 9, square root of 9 is 3. That works. This is my answer right there, right there. Let's go on to some more. Let's look at 6 here. Okay, this is going to be kind of a little funky one. So this is the one that's going to make sure we check. So again, number 1 is isolate. All right, isolate. Is my root by itself on this side? Yes, it is. So then we go on to 2. Raise both sides to the index. So this is a square, so I got to raise this both sides to the 2 power. Okay, so that gives me 72 minus m equals m squared. This is now a quadratic. If we remember, quadratic means I need to make one side 0. I'm going to bring this over and this over. So m squared plus m, right, I have to add this over, minus the 72, I have to subtract the 72, is equal to 0. How do I solve a quadratic equation? Remember, I can try to do it with this, negative 72, and this is just a 1, sorry, just a 1 there. This is 9 and negative 8. Now I have an equation, so I take these and I flip them, negative 9 and 8. Then I divide it by the a value, which is 1, but it's still negative 9 and 8, right? So we think these are our answers. And some of us are like, all right, I'm done. Let's go on to the next problem. I got to check. Remember, that was the 4th step. 3rd step was solve, which we did. We got 2 answers. The 4th step is to check. So I got to check. Let's check it out. Check it out. So let's erase this here so I can see what I'm doing. Let's plug it in. Let's plug the negative 9 in and see what happens. Square root of 72 minus a negative 9. Plus 2 negatives normally come positive. So that's the square root of 81 equals negative 9. So does this work? Hopefully we're shaking our heads. No. Why does it not work? Because anytime I take a square root, I'll never, ever, ever, ever be able to get a negative number. Never going to happen. Never. Okay? Never going to happen. I can't take a square root and get a negative because this negative 9 times a negative 9 equals 81. So a number times itself gives me the positive value. So the square root of this is never going to be a negative. Okay, it's always, this is a positive. Alright? Square roots of numbers are always positive values. Because I can't take a number, I can't take square root of that and make it a negative 9. Then, let's try the 8 here. 72 minus 8 is 64. Square root of 64 is 8, so that checks out. So the only answer that is acceptable here is m equals 8. Let's go to this one here, number 7. Again, I want to isolate, so that means I got to add these over. I get a minus 9 equals the square root 31 minus 3a. What? Yeah, now I got to raise it to the 2. Raise it to the 2 because that's the index. So the right side is 31 minus 3a. The left side, some of you are going to want to do this. Plus 81. And I'm going to be like, no. Because we have to do a box, right? A minus 9, a minus 9, a box. And what you get in your box is a squared minus 18a plus 81. You forgot the middle term if you did it kind of the bad way. If you just did this, you forgot the middle term, and that's not a good thing. So now, because I have a square, I'm going to bring the 3a over, the 31 over, so I end up with a squared minus 15a plus 50 equals 0. Let's factor using an x. That's 50, negative 15. This is 10, negative, and negative 5. I got to flip 10, comma 5, and divide by 1, so it's 10, comma 5. So again, I think my answer is 10, 5. Let's check. So let's put it back into the original equation here. We got negative 9 equals, a was 10, so now it's negative 10, plus the root of 31 minus, and then 3 times 10 is 30, right? So I got negative 9 equals negative 10, plus 31 minus 30 is 1, square root of 1 is 1, negative 9 equals negative 9, so the number 10 checks out. Let's see about 5. Negative 9 equals negative 5 plus square root 31 minus, and then this is going to be 15, right? Sorry, 15, not 16. It's going to give you 16 when you subtract it. Negative 9 equals negative 5 plus 31 minus 15 is 16, and the square root of 16 is 4. Okay, so I get negative 9 equals negative 1. Does that work? I don't think that's right? So the 5 is not an answer. That is what we call the extraneous solution. It is not an answer. So the only answer here is the number 10, and there you go. Let's go on to some other roots that are not square roots. All right, let's go on to 15 here. First, again, I want to isolate the root. I got to add 7 to both sides. That's a given, right? So the third root of n plus 4 equals 4. The second step was I have to raise it to the index. Well, what's the index on this one? The 3, so I got to raise them to the third power. When I do that, I get n plus 4. Remember, when I raise it to the index, I get what's inside, equals 4 to the third, calculator is 64, minus 4, n equals 60. Now let's plug it in just to be sure. 60 plus 4 is 64. The third root of 64 is actually 4. Minus 7 is negative 3, so that does work. So the answer, n equals 60, is your only solution for 15. Okay, let's go to here, 17 here. Well, again, I got to isolate. This is being multiplied, so I have to divide by that 3. Fourth root of x equals 3. What's the index? 4, raise it to the 4. Those go away, it's just x, right? Equals 3 to the 4th, calculator is 81. So then I have to check this. So 3 times the 4th root of 81 equals 9. 3, and what's the 4th root of 81? That's 3, equals 9. Does this equal 9? Sure it does. 9 equals 9, so this is our answer. That is it. One more example and we're done. Okay, let's go here to 20. Minus 1, that's a 4, equals third root of r. Index is 3, power is 3. That's 64 equals r. Let's check. 5 equals 1 plus third root of 64. 5 equals 1 plus third root of 64. You can calculate with this. Now, if we don't know what this is, really what we're doing is, remember from last section, we talked about we can write this as 64 to the 1/3. Remember, this is a 1, so 64 to the 1/3. The index is your denominator. You can plug this in a calculator, and you'll get 4. 5 equals 5. Therefore, this is our answer, and it does check out. All right, that concludes this video. If you need help on the next one, please tune in.